In this part, I wanted to talk about the practical part of the coding interview, because the theory part is rather clean and you can get all the information from books, but it's not necessarily reflecting the truth, or at least not in my experience. I wanted to go one by one through these points to show you that what is, in my experience, happening and what is the thing that is advertised. Asking clarification questions. It is crucial, it is very important, even though it will not serve the purpose that you think it should serve. So basically you have to narrow down which lead code question you're trying to solve, because there are quite some that look very similar but are not exactly the same. And if you solve the wrong one, then you of course obviously lose score or even fail the interview. They will not move you forward if you give an answer, correct answer, to the wrong question. And it's also relatively easy to get this part right, because the only thing you need to do is to ask these questions. And if you don't do it, then you lose score. And if you do it, then they will say in the feedback that it went very well. So be mindful about it. Don't spend too much time, because you only have, say, per question, you have maximum 20 minutes, not more than that. Even though it looks like it's 45, it's actually 20. Spend no more than 5 minutes trying to figure out which lead code question you're answering. Also, it is kind of a good thing that many people are very nervous. This interview is starting. Oh my God, it's this big company interviewing me. I have to say smart things and I have to look clever. And you already know what is the first thing that you will do, and that is ask the clarification question. And when that part is done, then you can move on to the next point. The next point goes about providing a small example. This will further strengthen your understanding of, okay, so we are talking about this exact question, plus it's almost like a requirement. So it is required that you give a small example, you try to solve it, and hopefully from the first point you already know which question you're solving. So this is really just a mandatory step to say that, okay, you're mindful about things, give an example, with something that you can finish in, say, 1 to 2 minutes. And the conclusion of this step should be that, okay, so if I give this input, is this the expected output? And if the answer is yes, then you can move on to the next one. If the answer is no, then you already know something went wrong in the first step. And maybe then this is the time to try to figure out what is exactly the question that you have to solve. Next step is that you have to try to get from interviewer that, do you have to make a full-blown class? Do you have to just write, say, a snippet, or do you have to give a function? You have to somehow decide what is the type of the input. If it's not in a typed language, at least the name of the input, and how the result should be presented. Is it just a Boolean saying yes or no? Do you have to print something? Do you have to return something? Do you have to return by reference? Do you have to return it as a copy? These are all important questions to answer. Usually this should be almost obvious, and the good part is that to some extent up to you. So if you think it will make your life easy, then you can also just assume that certain input is coming in, but make sure that you check it, that like, okay, so I think I need to have this parameter and that parameter, is it allowed? And maybe they will tell you that it's not allowed, or to make it exciting they will say that no, just assume that this is the only thing that you get access to. After concluding this point, you have to have something which says, this is my input, this is my output. Next step is to provide the most trivial but simplest solution, also known as the brute force solution. The point here is that theory and practice differs a lot, because in theory what you have to do here is to, say, come up with a trivial solution and try to improve on that. And what I found that in practice, this is not what you should be doing. In this step, what you have to do is state a trivial solution, but don't try to think ahead that this is going to be the basis for the optimal solution, because usually it isn't. Sometimes there is no way, or like not enough time to get to the optimal solution based on that original idea. The original trivial solution can be very misleading, so I would suggest not spending more than a couple of minutes on this solution. which is also in some way a sad thing, because what I got from reading the classic books, it gave me the idea that there is this 45 minutes, we start out with a very simple, trivially correct algorithm and try to improve it. Like, oh, let's look at the runtime, let's look at the space complexity, improve a bit here, improve a bit there, and we will end up with something. And even if it's not optimal, the thought process is the thing that is most important. And therefore, we can just say that we improved a lot, actually, compared to a brute force solution, and this is good enough. What I found in practice is that it is not good enough, and sometimes optimal solution is not resembling in any way the brute force solution. For the optimal solution, you usually need a lot of insight, some tricks. There is something hidden there that is not necessarily coming out just by trying to hammer on the brute force solution to try to see, like, oh, I'm duplicating the work here and I am doing unnecessarily work there. If you have absolutely no idea about the question that they ask, so it doesn't look similar to anything that you have solved before, then maybe the brute force is the best way to go, because at least then you solved something, or you gave a answer, and any answer is better than a no answer. So in that sense, just go with that. But what I found is useful is to try to say a basic solution, so not yet optimal, but the one that eventually can become optimal. How do I know that this train of thought will eventually result in the optimal solution? And for that, the simple answer is that because you have solved a similar question before. So you kind of know that this is going to be something like sliding window problem, or is it going to use a heap, or is it something which can be solved with a greedy algorithm. So all those things in mind, you can actually try to come up with the most basic, but something which can be then tweaked to become the optimal solution. So it's probably better to just go with their suggestion, even if you think it was actually correct what you wrote, because it comes down to, say, there is another dimension on which you're being evaluated, and that is not how well or how fast you could just push out the code, but how did you interact? Are you a person that is then later going to be able to work in a team? Try to keep up the communication with them. Take in their feedback as early as possible. So if they say that, oh, I think this is not going to work, usually they are right. And even if they are not, then you're better off just listening to them. I really hope that this was not too disheartening. I try to make it practical, because what you read in the books, what you read in the forums can be very different than what happens in real life. And I hope that you found this helpful. Which leads us to the next point, which is take this basic solution and try to tweak it until it becomes optimal. And at this point, optimal can mean many things. Usually optimality is in terms of space and time, but time is more important than space. This was already stated in the theory part, but just keep that in mind. So if you have, say, 1 minute left and you have a choice to optimize time or optimize space, then go for time. Once you arrive at the optimal solution in terms of time and space complexity, then you can start implementing it. And the implementation at this point should, well, with enough practice, it shouldn't be too hard if the train of thought is clear. So if it is for you clear how to do it, and for the interviewer it's also clear what you're trying to achieve. And I would say this is relaxing part, because if you forget the brace or semicolon or the parentheses, it's not the biggest deal ever. It is always advised to try to make the code look pretty, but it is not the most important. So don't have to overthink this part. Also, usually you don't have to run it, and honestly I don't think they have the time or the capacity, unless there is like an intern slaving away 24/7 trying to run everybody's code, because usually people make mistakes, and it is a well-known thing that if you would have access to an IDE or a compiler, it would tell you that, oh, you forgot to close the brace, then you close it, done. So it's actually not that important to have 100% correct code on paper. However, the algorithm part, the data flow, the logic what it's doing has to be correct, but not necessarily syntactically 100% correct. The final step, or the final step when you actually have to do something, is testing it. So plug in a small example. It can be the example that you already came up with in some previous steps. If time allows, then do more than one. So that way you can say that there is an edge case, here is the input, and my code is handling it well. There's another edge case for that you can come up with another input and say that, oh, it's also being handled. If you can do more than one test, then it also gives you confidence, and also it's always good practice to actually test what was being written. This will eventually lead you to the conclusion phase to say that, okay, these are the examples that I could come up with, these are the edge cases that I identified, and on all of them, plus also on the normal or generic case, it's going well. Based on these test cases and based on what we have discussed, it looks like it's working, and I'm confident that this is the final solution. At which point, usually you get some hints from them, or they will say something like, okay, sounds good, please move on. Usually then this is the part when you can relax a bit, that okay, I'm done. And what happens is that sometimes they have questions, and then it is up to you to defend the code that you wrote. It's always a good thing to, especially when it comes to, say, the algorithm itself, to try to be humble, because when they say that they identified a potential problem, more often than not, they are asking the same question, I guess, 100 million times. And for you, even if you did lead code and you solved it, say, 6 times in your life, they have seen all the solutions, all the pitfalls.